This is number 4 of 5, okay? So again, it's helpful that there's a picture. We don't have to graph it. I noticed that r is given. That's the equation here. And we're going from 0 to pi. Just to illustrate, just so you guys know, we're going from 0 all the way to pi. Okay? Cool. Let S be the shaded region. So notice how S is definitely not the entire shaded part because it's missing this section over here, right? And notice how it says S is just the third quadrant, the little part right here, okay? So here we go, part A. Write an integral expression for the area of S. So the only thing tricky here, we have 1/2 integral of r, which is 1 minus 2 cosine theta squared d theta. The only part here that you really need to consider is the bounds, okay? This definitely started at 0, but it did not stop at pi because pi is over here when you're traveling this way. So where did it stop, right? And sometimes you would have to actually do this part here. Where is this stopping point? Okay, notice how the radius is at 0 right there. R is equal to 0 at that moment. So what you can do is you can set your equation 1 minus 2 cosine theta equal to 0 because that's the moment where the radius is 0. This one is simple enough to solve by hand. Eventually cosine theta will come out to 1/2, and that happens when theta is pi over 3. You could even use a calculator if you're not comfortable with trig ratios there, okay? So you could just graph this and find your zeros. You'll end up getting something that's equivalent to pi over 3. So it should be, let's see, let me just type it out for you real quick. It should be around 1.047, okay? But because it's not the final answer, if you were to use a decimal, definitely go a little bit further so that you don't ruin your answer there, okay? Plug and chug, you get your answer. All right, here's part B. Part B is asking us to find the expressions for dx d theta and dy d theta. So x, remember, is r cosine theta, and y is the same thing as r sine theta. Notice how that tends to pop up a lot in the past few FRQs, right? We know r is 1 minus 2 cosine theta, and y is the same thing, 1 minus 2 cosine theta times a sine theta. Okay, so basically we have to find each derivative here, okay? So you do have to do this by hand because they're asking you for the general derivative, not a specific one. So dx d theta here would have to require the product rule. The first times derivative of the second plus the second times derivative of the first, which is 2 sine theta. And that's enough for you to just leave as is. You don't need to simplify it. Here is dy d theta. First times derivative of the second plus the second times derivative of the first, which is 2 sine theta. And you could leave it as is. Again, equal is equal. You don't get any extra points for simplifying. In fact, you lose points if you simplify incorrectly, okay? All right, here's the last one, part C. Write an equation in terms of x and y for the line tangent to the graph at where theta is equal to pi over 2. So right away when I'm reading this, I see write an equation for the line tangent to the graph. So that's the equation of a tangent line. So we need a point, an x and a y, and a slope, which is also known as dy dx, that's slope, right? So to find x at pi over 2, that would just require a little bit of a plug and chug here. So x would equal 1 minus 2 cosine of pi over 2 times the cosine of pi over 2, whatever that comes out to, okay? And then we're going to do the same thing for y, which is 1 minus 2 cosine of pi over 2 times the sine of pi over 2. Let me cheat a little bit here so that I don't have to evaluate it. X is 0 and 1. So our point here is going to be 0, comma 1. So we have a point. All we need is a slope. So remember that dy dx is the same thing as dy d theta over dx d theta. Notice how they kind of set you up for that right here in the previous part. Okay, so we need to figure out what they are, evaluate it at pi over 2. And you could decide to type all of this out on a calculator and evaluate it. Pi over 2 is pretty simple to evaluate. For instance, the cosine of pi over 2's would come out to 0. So this would be 0. This would also be 0, causing this whole thing to be 0 here. Sine of pi over 2 is 1. So this is negative 1 times 1 minus 0. So that looks like dx d theta comes out to negative 1. Hopefully I got that right, but I'll double check. Again, cosine of pi over 2 comes out to 0. So I know that this first term will come out to 0 because of that. This right here, sine of pi over 2 is going to be 1 times 2 times 1. So that looks like it's going to come out to 2, which is negative 2. Let me double check here. Boom. Okay, so now that we have a point 0, comma 1 and a slope negative 2, that's just going to be y minus y1 equals the slope times x minus x sub 1. I would leave it like this. No need to put it into slope-intercept form because equal is equal there. So that one was a little bit more doable. Okay. Now that I take a look at the scoring guidelines, really all of these points are doable. I would say the only one that requires a little bit of work is part C, but even getting 6 out of 9, that's good. Okay.